Okay, so this will be the last video for separable equations, and we're going to do just one more problem. Just one that's a little bit more involving, and what I will do is I have some of the busy work. I've already performed those operations, and I've just kind of captured them in a picture so that you can at least see what I did to get to the step that I got to. But okay, so the problem again, this time it says find the solutions, right? So, okay, so possibly indicating there's more than one. So find the solutions to the differential equation. And in this case, we're given some initial conditions, right? We're given the conditions that y of 0 equals 1 and y of 0 is equal to -4. So that's interesting. Well, okay, let's see if see if we can have some muscle memory here. So first things first, we want to go ahead and take that y prime notation. We want to take a look over to the right and see what other variable we're dealing with. So it looks like we're dealing with the x variable. So we want to write that as dy dx. Now, when all is said and done, remember we want to solve for y. All right. So as of now, we only have one technique, which is to separate the variables. So hopefully these can be separated. And we can do this fairly easily. We want the dx's to be on one side, the dy's to be on the other side. So if you can imagine, what I'm going to do is I'm going to multiply both sides of this equation by the denominators, right? So this dx would cancel from here. And that would leave me with just 1 plus y dy. And then, of course, this d1 plus y would cancel, leave me with just e to the x times dx. Okay, so at this stage, they are now separated. And as soon as they are separated, we want to integrate. So this is fairly easy integration. So if you integrate 1 with respect to y, it's going to be just y. If you integrate y squared with respect to y, so we're going to have y plus 1/2 of y squared, or y squared over 2 if you'd like, but 1/2 y squared. And of course, if you integrate e to the x with respect to x, it's just e to the x. So plus c. All right. Now, remember, our goal is not only to solve for y, but to go a little bit farther and find the solution with these initial conditions. So what I'm going to do here is I want to make like, I'm trying to solve, I want to solve this equation for y. And I'm going to make life a little bit easier on myself by setting it equal to 0. And then, but before I set it equal to 0, I'm going to go ahead and distribute a 2. So that's going to be 2y, and notice that leading term, the 1/2 y squared, once I just multiply by 2, then I'm just left with y squared. Okay? So let's go ahead and distribute that 2. And let's set it equal to 0. So we want to times by 2 and set equal to 0. Ready? Let's go ahead and do that. So let's write it in descending power. So let's start with the y squared first. So that's just going to be y squared plus 2y. Now, when I take this entire term and bring it to the other side, It's going to have to change the signs, and I still have to distribute that 2. So that's just going to be minus 2 e to the x plus c. So now I set it equal to 0. So, all right. Does this resemble something that you have done in previous math courses? Well, it should resemble a quadratic, right? And if it's a quadratic, then we can use the quadratic formula, right? Just in case, FYI, in case you ever wondered where the quadratic formula came from, if you take this quadratic equation and you complete the square, you would have the quadratic formula. But nevertheless, you know, what I would have to identify what is A, what is B, what is C. So now I'm going to go to the next page, and you're going to see a block of text from which I've already done the computation of the quadratic formula. So don't get stressed yet, right? So first off, let's just figure out. So this is our quadratic. So in this case, A would be equal to 1. That's easy to see. B would be equal to 2. That's easy to see. But C, which would be the constant, well, that's going to be this entire term. And that should make sense because remember the initial conditions were y of 0 equals. So that means that you are plugging 0 in for x, right? So that is just one big constant. I understand that that's not the type of quadratic formulas that you're used to, but nevertheless, so here's our quadratic formula. And what I'm doing here is you can just see I'm kind of working out the algebra necessary to get to this this last step. And what is that last step? Well, remember that the quadratic equation, right? So a quadratic formula is a way for finding roots, right? A root is where your y, well, let me not go into what a quadratic formula is. I think you kind of got the gist. So what is this? Well, this is when x is 0, or we have, let me write that better. We want to write it as y of 0 is going to be equal to, and all I'm going to do at this point is copy that last step. So -1 plus or minus. Now 1 times, so I'll get rid of the multiplication by 1. 1 plus 2 times e to the x plus c. All right. Now, at this stage, we're going to introduce those initial conditions because we need to figure out what the value of c should be such that those initial conditions are met. So I'm going to grab this, and I'm going to go to the next page. Okay, so I've literally just copied that from the next page, or the previous page. And the initial conditions, if you were to go back to the very first part of the problem, were y of 0 is equal to, let's see if I can remember, 1, and y of 0 is equal to, it was -4. So what we're going to be doing is we're going to be plugging 0 in for x and setting this equal to 1. We just need to make sure we take the right root, right? Either the negative or positive version of the root. So for starters, since y of 0 is equal to 1, we're going to only focus on the principal root, the positive root. So that's -1 plus the square root of 1 plus 2. Looks like I forgot my parenthesis here, and probably here too. Yep. 2 times e to the power of, now this is to the power of 0. Right, so that 0 is going here. E to the power of 0 plus c. Let me go ahead and set up the right side as well. So the -4 will be going here. That 0 will be going here. So that's -4. So now, since it's equal to a negative, we're going to take the negative root. That's going to be e to the power of 0 plus c. All right. So what's left here is to solve for c. Well, e to the 0 is 1. So I'll try to be quick. So 1 equals -1 plus what? Well, I think you can see that if I have 2 times 1 and then 2 times c, and so 2 times 1 is 2, plus 1 is 3. So plus the square root of 3 plus 2c. It's going to do that over here. -4 is equal to -1 minus. In this case, we should have, again, 2 times e to the 0 is 1. So this is going to be the square root of 1. No, that's going to end up being 3, right? Because 1 plus 2 times 1. So 3 plus 2c. Okay, so we can go ahead and, we can bring this 1 to the other side. We can bring this -1, I should say, to the other side. So we end up with 2 is equal to the square root of 3 plus 2c. And we end up with -3 is equal to the negative square root of 3 plus 2c. All right, well, the only thing left to do is going to be to square both sides, right? And then solve for c. So I'll do that on the left side, and then I'll just give you the answer to the one on the right side. So if you square both sides, we got 4 is equal to 3 plus 2c. Therefore, c is equal to 1/2. Same thing here. We would have c is equal to 3. All right. So what are remember the goal, let's go, we've done a lot of work and we are almost basically done with this problem. Let's go back to the initial question. Find the solutions with the initial conditions. So right here, you had the general solution. But now we're going to be taking this c equals 1/2, c equals 3, and we're going to be plugging it in here so that we have the two particular solutions. So the two solutions to this problem, so we got y of x equals y of x equals, it's going to be -1 plus, it could be -1 plus, let's see here, c is equal to 3, and c is equal to 1/2. So plugging in a 3 here, you'd have to have 2 times 3. You have to do a little bit of arithmetic here, plugging a 1/2 in there. So we end up with the square root of 2 plus 2 e to the x square root of 7 plus 2 e to the x. You see how I did that, right? If you go back up here, and you now are in essence plugging in 1/2 for c. And then just simplify that, right? You just got to just simplify now that c is a half. You would get the following. Or plugging 3 in for c. Again, you'd have to simplify that out a little bit, and there you have it. So these are the two solutions to that initial value problem. And we'll conclude. That is, you'll need some practice, but that is the separation of variables technique.